we're on unit 3.7 to 3.9 of calculus, the open book test. We're on question number 3. And what it says is approximate the zeros of the function, use Newton's method, and continue the process until two successive approximations differ by less than 1,000th. Okay, so I'm going to shift things up here so we'll have a little bit more space. I'll make it where the calculator could be over here because we're going to do this in the calculator. And I'm going to kind of try to explain on the first one and write some notes and some things like that. Okay? All right. So the situation is, and I'm going to write it way down here. The situation is that if we had y minus y sub 1 is equal to slope times x minus x sub 1, that is the point slope formula line. Now, what's happening is we're saying if we're going to use a specific point, if we're going to use a specific point like x sub n, then the y value of that point would be the function value at x sub n, right? That would be my y1. My y1 would be the function value at x sub n. The slope would be that that slope would be the function value of the derivative at x sub n. Again, the y sub 1 would be the actual function value at that point x sub n. And we're wanting to find, in this situation, we're wanting to find the intercepts. So we're wanting to find the value of this x when this y is equal to 0. Okay? That makes sense? So, in place of m for slope, we're thinking, okay, the derivative gives us the slope of the tangent line at any point, and if we plug in our point x sub n, then that's going to give us the slope of the tangent line at that specific point. If we find the y value at that point, then plug in a 0 for the first y, we're going to be able to solve for that x. Now, if we manipulate this formula, then I'm going to bring it up here, and then I'm going to get rid of this manipulation. We would have 0 minus f of x sub n is equal to f prime of x sub n times x minus x sub n. We want to solve that for x. So that 0 is going to go out. I'm going to divide off the f prime of x sub n, divide off the f prime of x sub n. And what I'm going to have then, those are going to cancel. I'm going to have x minus x sub n is equal to f of x sub n over f prime of x sub n. Okay? And then if I want to find my x sub n, I would subtract x. I would have negative x sub n is equal to, actually I'm wanting to solve for x. Excuse me. I'm wanting to solve for x, so I'm going to add x sub n to both sides. And so I'm going to have x is equal to x sub n plus f of x sub n over f prime of x sub n. And you can see I made a mistake when I slashed out. I lost my minus sign there. There's a negative right there. and I need it on here when I divide it off, and I need it right there. And so that's going to make that a negative, which makes this a minus, and I apologize for that. I slashed out my minus sign and then I didn't grab it back. I knew there was a problem, but I wasn't seeing it. I had to pause and go find it. Okay, so the value of the x is equal to x sub n minus f of x sub n minus over f prime of x sub n. I'm going to pause the video just a second. Okay, now let's go back and think about what we're doing here. If we had a graph of this function, first of all, it's an x to the third power, so we know that the graph is going to look something like that, right? And it's going to intercept the x-axis somewhere. Now, let's just kind of guess. If we made that a 0, we'd think, well, what would it take to make that a 0? Well, if I put a 1 cubed plus 3 is 4. Well, what about 1/2? 1/2 cubed is 1/16, 1/8, so that's not going to work. We need a negative something, right? A negative 1 cubed is a negative 1 plus 3 is a 2. Now we're getting closer. So maybe we could just say, maybe negative 1 1/2 would kind of eat up that 3. You see what I'm doing? So I'm going to kind of make a guess. That my intercept is approximately negative 1.5 and 0. Okay? Now, just for purposes then, I'm saying, okay, if this is negative 1 and this is negative 2, then I'm not sure what my graph looks like, but I know that my intercept is somewhere in here, right? And what I want to do is I want to find a tangent line that's really close by. I'm sorry, I'm going to try to find the slope of that tangent line, and I'm going to find the x-intercept of that tangent line, and it's going to be really close to my right answer, right? Remember that in the other video. So what we're doing is, instead of saying, okay, I think it's somewhere between negative 2 and negative 1, and my graph is here, and so I'm going to try negative 1.1, and I'm going to try negative 1.9, and then I'm going to narrow down. Instead of doing that, we're trying to find a point on it and find the slope of the tangent line that goes through it, and then we're going to find the intercept of that tangent line, which is going to get us there faster than easing our way in, okay? All right, and so this is that value of x that would give us that 0 of that tangent line that's going to get us really close. So we're just going to keep doing that until we get so close that our changes from one x to the next are so minimal that that we're not going to really we'll realize there's not much error left in our problem. Okay, now I'm going to wipe out this part just to kind of get it started. Do a little bit of erasing up here, and we're going to build a chart. Okay. Now, on my chart, I'm gonna set it up like this. I'm gonna set up n, and then I'm gonna have x sub n, and then I'm gonna have, I may need more space. Let me just back up a little bit. I'm gonna have n, I'm gonna have x sub n, I'm gonna have f of x sub n, I'm gonna have f prime of x sub n, I'm going to have f of x sub n over f prime of x sub n. And then I'm going to have, if I can get it in, x sub n over f of x sub n over f prime of x sub n and this is going to be my next x sub n. See, and I'll start over. Okay? Now, all I'm doing with the n is saying, okay, this is round 1, round 2, round 3, round 4. That don't really mean that much to us. Round 1, round 2, round 3, however many rounds it takes us to make this happen. Okay? I'm going to let everybody catch up writing that. Now, I'm going to highlight just so we understand, x sub n was this second x value, right? And f of x sub n is my second y value in my point slope formula. F prime of x sub n is the actual slope of the tangent line at that point. So when I put, when I go to solving this, then this final thing, f of x sub n minus f of, I'm sorry, x sub n minus f of x sub n over f prime of x sub n ends up being my new x, right? Okay, and that's why I can take that and bring it back over here and start my round again. Okay, everybody understand what's going on here? Now, we're going to do this in the graphic calculator, and I'm going to go ahead and do this in green. My very first choice is going to be my guess. Now, I made an estimated guess in my head, and then we're going to plug those in. Now, we're going to do this in the graphing calculator, okay? So I'm going to let the graphing calculator do these calculations, but before I can, I need to go ahead and find my first derivative, right? So I need to find f prime of x, and f prime of x would be what? 3x squared. So that was a pretty simple derivative. Okay? Now, we're going to do this in stat edit. So I'm going to go to my graphing calculator. You can pull yours up. And I'm going to turn my calculator on here. I'm going to try to bring my writing back up so we can see both. And so I'm going to hit stat. And I want to edit. Yeah, I want to edit, so I'm going to hit enter. Now, in L1, I'm just going to put my round number. It's not going to mean anything. And so in L1, I'm just going to put round 1, round 2, round 3. I could just leave that off, but I'm just doing that. And then in L2, in L2, I want to put my first number, which was negative 1.5. Negative 1.5. That was my first x sub n, okay? So my L1 is representing, my L2 is representing x sub n, okay? And I'm going to hit enter. Now when I go to L3, I'm trying to calculate the function value at that, right? So I want to write a formula. Now this is important. When we write a formula, we go to the top. So I'm going to write over and go to the top. See how we got to the top? And I want to lock my formula in. To lock my formula in, I'm going to hit alpha plus sign. You see the little double click like this, inches, you know? Alpha plus sign. It's going to put it in quotes. And then I'm going to put in my formula. And my formula is x cubed plus 3, but I wanted to pull from the stuff I put in L1, right? So I need to tell it L1 cubed. So I'm going to hit second 1 for L1.
L2.
Thank you. I need to hit second 2 for L2. Thank you. Raised to the third power plus 3. I'll do that. Putting those counting in L1 was going to mess me up. And then alpha quote, we want to lock in that formula. Okay? And then we're going to hit enter, and it's going to calculate it. And notice it put a key there. That means that that formula is locked in. That way, when we go to put another one in, it's going to work for us. Okay? All right. And then in L4, we wanted the function value, the first derivative value at that x. So now we're given the slope of the tangent line at that point. And so we're going to go to the top. We're going to go alpha quote. Remember that the derivative was 3x squared, right? We're going to have 3, second 2, which would be L2. And that's the end of our square, 3 L2 squared. Alpha quote, and we lock that in. So that gives us the slope of the tangent line at that point, you see. Okay, then we hit enter. And then the next thing that we wanted was the function value at the point divided by the derivative value at the point, right? Which would be what? You can look at your notes. Let me pull the notes back up so you can see what we're wanting to do. We wanted the so in L1 we have this, in L2 we have this, in L3 we have a formula for function value.
So it'd be L3 about L4.
Good. In L4 we have the function, the derivative value. So L3 the function value, L4 the derivative value, L5 we want L3 divide L4. L3 divide L4. See that? Okay? So we're going to go back to our calculator. We're going to go to the top. We're going to put it in quotes so it locks it in. And we're going to tell it second 3 divide second 4. Alpha quotes. I missed my quote. Hit second instead of alpha or something. Alpha quote. And then we have that. Now, if we go to the next thing, I'm going to pull my writing up again. The next thing is x sub n minus that answer. Now, this part right here is my L5 now, correct? And my x sub n is my L2.
L2 minus L5.
So L2 minus L5. Good. So I'm going to go to the top. Alpha, quote, second 2 minus second 5, alpha, quote, enter, and now it's all locked in. Now we guessed negative 1.5, right? We guessed negative 1.5. Now I'm going to back up here because here's what's going on. I need to write all that stuff in here, right? And it's not staying there. Wish it would.
If you skip the screen of the writing board over a little bit past the calculator, it would work.
Oh, if I minimize my writing board.
Yes, and just make it as big as the space you
You're right. I was trying to minimize the other. I wasn't thinking like that. You're right. Need to minimize my writing board to go with the other and quit knocking it out. You tried to tell me that while ago, and I was stuck on the calculator. Okay. Now I can bring my writing back. But my writing's going to be as big as the other. That's my problem. Yeah. So,
Read it.
that's okay. We'll just go back and forth here. Okay, so y'all have the numbers in your calculator. That's fine. So what did we end up with in all of these spots for that one? What was in your L3?
Negative 375.
What was in L4?
6.75.
And then the next one,
negative 0.0556.
and the last one.
Negative 1.444.
Okay, so the next thing that goes into my x of n is going to be the negative 1.444, which wasn't too far from our guess. So we want to go back and plug in the negative 1.444. So we'll put our calculator back up. And the nice thing is we can just go over here to L2, and we can put in negative 1.444. And because our formulas are locked in, when we hit enter, it's going to do all the calculations for us, all the way across, see? Okay, and I'll just let y'all call them out. So what did we get for that one?
Negative 0.0109.
And
6.2554.
and
Negative 0.0017.
and
Negative 1.442.
now the directions said go until you have a discrepancy of less than 1,000th on your new x of n, right? Now we're 2,000ths off now, which means we need to do another round. You see what's going on? Okay, so we got negative 1.442. Okay, and then we're going to plug that in. So negative 1.442. You see it's important to take it out a few decimal places. Enter. And we get some new information which we'll plug in, and we're going to have
0.00156.
0.0156.
6.2381.
Okay.
2.5 exponent to the negative 4.
So it'd be, so go over 4 places. 3 zeros, 2, 5.
Okay.
And negative 1.442. Yep.
So we are less than 1,000th discrepancy. So we're going to say, well, we must have gotten to that approximate zero. So we're going to say my approximate zero is negative 1.442. Now we guessed it at negative 1.5, so we weren't bad on our guess. But understand what we did. Now, so this was my L sub 1. This was my L2. This was my L3. This was my L4. This was my L5, which was L3 divided by L4, right? And this was my L6, which was L1 minus L5. Okay? In case you need to write that down. That's kind of how we got to it. L2, thank you. Go back to that one again. Wow, you keep saving me on that. L2 minus L5. You might not even, it might have been better just to not even put that round whatever. Anyway, everybody still got that? Okay? All right, well, we'll go to the next one. Once you get that down, it's not too bad. It looks kind of intimidating when you begin. All right, so we're going to go to number 4. We're going to think about this. When you think about fourth power, you're going to be thinking about a U, right? A parabola-looking thing. Now, remember, there's going to be 4 solutions, but 2 of them are probably imaginary solutions. So there's probably only 2 solutions that we can actually find zeros for. So that's what we've got in our mind. It was positive, so it opened up. So let's just kind of estimate. We need to wipe out a -3. Now, if I made that a 1, that would make that a half, and that would be a -3 and a -3, so I'm way off. I need it a little bit bigger, right?
Right.
If I made this a 2, 2 to the 4th would be 16. Half of 16 is 8. -3, 3 times 2 is 6, so that's a -6 and a -3, so that's a -1. That's not far off of a 0. So I'm going to guess one of them at +2. See what I'm doing? Okay? I can try to graph it or something, but I'm just trying to do it in my head. Okay, what else would make a 0? Well, if I had a negative number, let's just say I had a -1. -1 to the 4th power would be a +1. So that would be a half, and that would be a +4, right? And that would be a -3. So we're off by half, or 1.5. So that's not too far. So I'm going to say one -1's not a terrible guess. I'm not so far off I can't zoom in with my slopes of my tangent lines and all that kind of stuff. So I just did some kind of close guess to what they might be, okay? All right, and then I want to find my first derivative. So my first derivative is going to be 4 times a half is 2x to the 3rd minus 3, right? 2x cubed minus 3. And then I'm going to set up my chart. I'm going to have n round 1, 2, 3. And then I'm going to have my x sub n. I'm going to have my f of x sub n. I'm going to have my f prime of x sub n. I'm going to have my f of x sub n over f prime of x sub n. And then I'm going to have my x sub n minus f of x sub n over f prime of x sub n. And this is going to be my L1 and my L2 and my L3 and my L4. And this is going to be my L5, which is going to be L3 divided by L4. And this is going to be my L6. I didn't subscript that 5. That 5, that was weird that it jumped up there. This is going to be my L5, which is L3 divided L4. And this is going to be my L6, which is L2 minus L5, right? Okay. And we're just going to go to the graphing calculator and punch all of that in. All right. Well, it's not going to matter because I'm going to lose it anyway. Okay, I'm going to go ahead and leave the 1, 2, 3. I'm going to go up to the top, hit clear, and down, and clear that out. It doesn't like that. But that's okay. Up, clear, down. Up, clear, down. Didn't like that. It's that. I should have cleared out the last one first. You can do second plus 7, 1, 2, enter clear. It's not liking me to do this.
I did the second plus and 1, 2. It worked better.
Yeah, I've got a program I don't want to lose, so I don't want to do that. Yeah, so if you do if you do your second plus 7, 1, 2, enter clear. Okay, I didn't want to do second plus 7, 1, 2, enter clear because I had some formulas in my calculator that I didn't want to lose. Okay, so looking at our stuff, then we've got the first derivative and all of the things that we need. We're going to just have to either start with the 2 or the -1. We've got to do this twice on this one because there's 2 possible zeros. So I'll just start with the 2 there. So I'm just going to put in a 2 for L1. I'm going to go to my L3 and I need to write a formula. So I go alpha plus sign to lock it in. I'm wanting the function value, so I need to plug in this formula. So I'm just going to use 0.5. So 0.5 for a half. L2. And then raised to the 4th power minus 3 times my L2 again, and then minus 3, and then alpha lock. So we got that. Alpha plus. So we got that in there. Okay. We're going to hit enter, and it's going to calculate it. It put a key in the lock and locked it. We're going to go to the top. Now we want the derivative value. And remember, my derivative was 2x cubed minus 3. 2x cubed minus 3. So I'm going to the top on L4. I want to alpha plus sign, lock it in. It was 2x cubed, so 2. My values I put in L2 again, so 2L1. Raised to the 3rd power, and that was a minus 3, is that correct? Yep. Minus 3, and then we want to lock it in. And we hit enter, and there's that one. In L5, we wanted L3 divided by L4. We wanted the function value divided by the derivative value. So we're going to alpha lock. And we're going to do second 3. Divide, second 4, alpha lock, enter. And then in my L6, I want it to be my X value, which we had in L2, minus that quotient there from L5. And I didn't lock it in. So alpha plus sign L2 minus L5, lock it in. There we go, enter. All right, and we get the first round of stuff, which was what? We had guessed a 2. And then we had what? What's all your stuff? Negative 1, and then
13.
And then
Negative 0.0769.
And then
2.0769.
thank you. And so our guess of 2, we weren't far from it with that 2.0769. That's going to become our second estimate of our X value. Understand what we're doing? So we go back to the calculator. We go back to our L2. We're on round 2. We're going to plug in the, what was it, 2.0769. We hit enter. And we get another set of data, which y'all can call out again for me.
0.0725.
0.0725.
14.917.
Okay.
0.00486.
And then
2.072.
all right. Now, at this point, you can see that we're off by 4 thousandths. We want to be off by 1,000th, right, or less. And so we need to go another round. So we're going to have 2.072 as our third input. 2.072. So we come back in to our L2. 2.072, enter, And we have,
Negative 3 exponent of negative 4, so negative 0.0003.
0.03. And then we have
14.7.
okay,
And it's negative 0.00002.
okay, and then,
Q2.072.
and so we have no discrepancy in the thousandths place, so we're happy with that. And so we're going to keep the 2.072, and that's the value of x when y is 0, right? So we very closely approximated one of the intercepts. And now we need to go for the other intercept, right? And so I'm just going to come down here and start numbering again. 1, 2, 3. And my first guess this time is going to be the -1. We started our first round with a guess of 2, and we're starting our second round with a guess of -1. Okay? And we should be able to zoom into that -1 just like we did. Now, my equations haven't changed, have they?
No. All you do is
So I can just leave all of that stuff in there. And I'm just going to go over here and put round 4, 5, and 6, except it's a brand new deal, right? I don't really need anything in there. But, anyway. So I'm going to go there with the -1. Hit enter. It's already all my equations already in there. Okay. And so I can start with my second guess. Okay. And so my data for that is 0.5,
-5,
-5,
-0.1,
-0.1,
-0.9.
-0.9. So I'm going to bring my -0.9 over. Doesn't look like we were pretty close to that. And then we're going to plug it in again. I'll just let y'all do it instead of going back and forth on the video. You're going to plug in the -9, and you're going to get what data?
Negative 0.02805.
And then,
-4.458.
good, and then,
Negative 0.0063.
and then,
-0.8937.
and we plug that back into the front, -0.8937, and we get
6.1 exponent of
zero,
Four zeros.
0.65.
6.1.
1. Got you? The 5 is there. Okay. All right, and then the next thing is
-4.428.
okay, the next thing is
Negative 0.00001.
and the next
And negative 0.8937.
all right, and so we're good in the thousandths place, and so we're going to say that our approximate 0 is negative 0.8937 0. My other one was
2.072.
0. So we found very closely a very close approximation of the two intercepts of that coordinate. Pretty cool. Any questions on that? That was actually lesson 3.8, and we still have lesson 3.9 for this packet. Appreciate your